Thanks, Venkat. Hello, everybody. Thanks for joining this presentation. My anticipation, guys, that the reason why you have joined this presentation or watching it afterwards is that you are already deploying Apache Ignite in cloud environments or are planning to do so. And in particular, as part of those deployment strategy, you are thinking to use serverless functions that should connect to your cluster, Ignite cluster, and do some exercises. And right now, you might be sitting and wondering, like, what are the best practices for this type of deployments when we have an Ignite cluster in the cloud and serverless functions connected to it? And if we talk about best practices, what type of client connectivity should I use? If I select a thick client, that what would be the startup time? If I go for the thin client, that will I get a good latency for the response time? You might have all these tons of different questions that needs to be answered. And honestly, I had the same questions. I questioned myself similarly several months ago. I was sitting and thinking, all right, I want to figure out if Ignite has everything needed for the serverless architectures. And I decided to do a research. And today I want to share the first base of that research with you. I'm going to continue to moving in this direction, and this recording, this material, different other materials are going to be improved in the future. But today we are going to answer several major topics and to focus on several things. First of all, we all understand like the point of serverless computing, at least that's the anticipation I have. And the first goal would be to find out what's the real value Ignite can give to serverless architectures. Is there any real profit? And if yes, how exactly can we measure it? The next obvious step is, let's say, yes, right now we have the cluster in the cloud, and I need to connect, I need to develop a serverless function and select one of the main Ignite connectivity options. And there are so many of them. You know that we have thick clients, we have thin clients, we have REST protocol, we have all sort of different SQL drivers. And which one to go for? That's the question that's one of the questions we are going to review today. Once we address those first two items, we are going to take a break, from the theoretical point of view, and I'm just going to show you how quickly we can create a simple serverless function for Azure Cloud, start it, deploy it, etc., so that you have a basic understanding to how to start doing that. And finally, we will finish this conversation reviewing just Ignite cluster deployment options, even though that's not kind of that's not somehow related closely to serverless deployments, but still, many of you are interested in self-service or managed service options for your Ignite cluster deployments, and we'll just spend probably 5 minutes there. Okay, let's move on. Serverless computing with Ignite. And the question is, what's the profit? What's the value? If to remind ourselves, what's the primary objectives of serverless computing architectures? It's all about cost savings. Because we already moved to the cloud environments because we want to save our costs. We would like to deploy everything in scalable and manageable environments. And the serverless computing is the next move. And what do we mean under that? When you're running your serverless function, you're paying only for what you use. It's like when your function is not used, when your function is idle or is not being executed, you're not paying anything. You're not paying for compute, you're not paying for CPUs, you're not paying for any other resources. If to be more specific, let's recall what we are being charged for when we deploy our very first serverless function. First thing first, we are being charged for the number of requests that hit our function. If you take a look on the diagram to the right, you can see that like at 5 a.m. Our function was executed let's say between 23 or 24 times. But let's say in several seconds from that time, between 5 seconds and 5 minutes and 1 second, there was a gap. It was not being executed. So whenever you see those requests, it means that the function is deployed, the function is running, and you're paying for it. But also when you see those gaps or caveats, that's when we are not paying anything to the cloud provider. And that's how we can reduce our costs. Also, the request count is not the only one billable item. You are going to pay for the function execution duration. And that's the most interesting criteria for us, because the longer your function executes, the more you're going to pay. And here is we can come up with all sort of with a myriad of different optimizations so that we can reduce our function duration time and pay less. And also behind the scenes, someone sitting and deploying and managing all the serverless functions for us. And basically that's a special managed service group of your cloud provider. Because yes, you deploy this function, but then this function needs to be scaled to accommodate your growing, to accommodate your application load. You might have, let's say, at one point in time, you might have only one instance of the function deployed, but then in a few minutes, you might have 3 instances deployed because right now their requests have sparked, etc. And someone does this, right? And you're at least paying for that as well. That managed service offering stuff is just embedded into the price of your serverless function offerings. And right now, I want to ask to break down the duration, the execution duration time, because that's exactly the place where we can see Ignite can be helpful for your serverless functions. When we talk about the duration, if to put it simple, I would split it into 2 items. The first one is the startup time. When a query arrives, the cloud environment needs to bootstrap your function and to do all the loading procedures. That's the startup time. But once your function is up and running, it's going to execute its logic, the logic it's being created for. And here is we can go further. We can split the logic execution time onto the local logic execution time. So basically the code that will be executed inside of the process of your function, but also there is the remote logic execution time. Because I do believe that in most of the use cases, your function is going to reach out to a remote database or to your microservice or any other API, and that will be and that kind of round trip and execution, you can think about it as of the remote logic execution time. All right. So what's next? And here is if to talk about the remote logic execution time, that's exactly the place where Ignite can be instrumental and useful for us. And why? Because Ignite is in a memory computing platform and memory database or cache. As soon as your function connects to Ignite and sends any request, once that requests arise in Ignite, Ignite will be able to execute it the fastest way possible, serving all the data from memory. But also at the same time, we can have a negative impact into this duration if we select not the best or not the most optimal Ignite connectivity option. Because when your function is being started, when your function will be connecting to your remote Apache Ignite cluster, we can think about this as of the startup time. And depending on your client connectivity option, your startup time can be really rapid and swift, or it can be sluggish and slow. And with the next section of this exercise, let's review some of the Ignite connectivity options. Basically, we have plenty of them, and right now I want to give you some suggestions, which one to use and in what circumstances. The very first type of client connectivity, thin clients. My personal, after guys doing this research and after doing different exercises, I would say that thick clients, even though they are the most widespread and the most prominent connectivity option across Ignite applications and microservices, I believe that those are not the best fit for the serverless functions. And let me explain why. Because they will have the slower startup time. And this happens because the client, your thick client, when it connects to the cluster, it has to wait while all your server nodes become aware of its existence. If you take a look at this diagram to the right, in square, we have the client that is connecting to the server. It will send a join request to one of your servers, and then this join request should be processed and sent over the whole cluster ring, so that every node, every server node becomes aware of this client and actually approves this join process and basically takes this client into the cluster topology. And this takes time. And the problem is that, let's say, the more servers you have, the longer will be the startup time of your serverless function. And that's exactly what we would like to avoid. We are paying for the function execution time, for the startup time. And unfortunately, with the thick clients, the startup time should be the longest if to compare to other Ignite connectivity options. Another thing is that when it comes to Java, that's okay, but also the thick client also exists and available for .NET and C++ applications. And the problem here is that when you're starting those C++ or .NET thick clients, that Ignite will start a GVM process internally. And this again will dramatically increase the startup time of your thick client-based serverless function. But anyway, like if to look at this from a different perspective and ask ourselves the following question: is there any reasonable usage scenario for our thick clients? And I would say that yes, a reasonable and probably usage scenario exists. For instance, if your function traffic is consistent, like it's shown on the diagram to the right. So when your function is basically loaded once by your cloud environment, and then the cloud environment doesn't return or unload this function, then it's okay. You basically start, this function is started, you connect it once to your cluster, and then probably the next 5 or 10 minutes, the cloud environment will not unload it, because there is always some, small but consistent traffic. It's like what's shown here. We have around like 2 or 4 or 6 queries every, let's say, 10 seconds or 20 seconds or a minute. And in this case, the cloud environment, like if to talk about AWS, for instance, your function can be automatically unloaded if it's not being used for the next 5 minutes. But if it's being called, then the chances are high that you just connect it once and you don't need to repeat this for every given query. So if the traffic is consistent, then thick client probably is, you can think about the thick client as a possible option. Or you might select this thick client if you need any API that is not supported by our thin clients that we are going to review next, or by the REST protocol. For instance, what's not supported right now, the thick client supports machine learning APIs, they support continuous queries, they support data streaming. And probably if you need any of this for your serverless function, then you need to look at the thick clients. If for any reason you decide, if you determine that your traffic is quite consistent, low but consistent, and you want to use a thick client inside of your serverless function, then don't forget to enable this flag, TCP communication SPI force client to server connections, to ensure that your serverless function, that your thick client doesn't open any incoming TCP IP connections. So generally, you don't want to have any server socket connections opened on your server function. And for instance, Azure will not be able to, will not allow you to start any server socket connection. AWS allows, but with some restrictions. So generally, just remember about this flag. When it comes to the next type of the client connectivity, thin clients. After the same research, I concluded that probably the thin clients, you should default to the thin clients when you are developing any serverless functions. And my judgment is based on the following, because these thin clients will connect really fast to the cluster. It's, just like an open TCP connection with one of the servers. Take a look at this diagram to the right. You have your application, which basically in the serverless world will be your serverless function. This serverless function application creates a thin client connection, and thin client just needs to connect to one of the servers, just one TCP connection, and that's it. After that, all the queries that your serverless function is going to send to the cluster will go through that server. After that, the other benefit of the thin clients is its cross-platform capabilities. It's really lightweight. And what I mean under that, when you are going to create any .NET or Python serverless function, and Ignite thin client doesn't start any Java virtual machine internally. That's what happens with the thick clients. And that's great. It's like gives you some, common and standardized API of Apache Ignite, which can be reused and exactly the same across all these programming languages. And also, it's fair to say that the thin clients is getting more features, is becoming a more feature-rich type of connectivity. For instance, right now in Apache Ignite 2.8, we already support SQL key value and transactional APIs, but at the same time, the next version of Ignite that is about to be released this or the next month can boast about the compute capabilities, service APIs, and some cluster APIs. So that the client is getting really feature-rich. And finally, even though the community did not work on the 2.10 release yet, but we already have accepted the contribution for the continuous queries API support. So I would say that sooner or later, the thin client and thick clients will achieve a feature parity. All right, and also if to mention another type of connectivity that you can use for a specific type of deployments is Ignite REST protocol. That one I would suggest using if you need to generate or create a Graal VM native image for your Java-based serverless functions. So when we, again, if to start this comparison with the startup time of your function, I would say I was not doing any measurements, but my guts feel and my kind of understanding that the startup time of the REST, the startup time of your serverless function that uses REST protocol should not be different from the function that uses the thin client connectivity option, because it's like if you take a look at the diagram to the right, every Ignite server node has an instance of a Jetty server running. And when you are going to connect to this cluster to execute any command through the REST protocol, basically you again need to open an underlying TCP IP connection to that Jetty server, and then you will be sending HTTP commands over that protocol. So it's like, that's why I'm thinking that the startup time will be compared between REST protocol and thin client connectivity options will be the same or comparable. And again, if to summarize why I am bringing up this connectivity option in this conversation, that's for those who are going to create Java serverless functions. And if you'd like to use Graal VM native image capabilities, then that's the place to go, because right now neither Ignite thin clients nor thick clients support will allow you to generate a native image, because we use a lot of reflection code, we use unsafe operations. Those thin and thick clients will be optimized. So I think that in the foreseeable future, it will be possible to generate native image for the thin and thick clients. But if you need this native image right now, instantaneously, you're not ready to wait, then just use Ignite REST protocol. And if you go for this approach, don't forget to enable Ignite REST HTTP module. Okay. And that's a reference where you can find the latest documentation on that matter. If to summarize, okay, here is, we reviewed different connectivity options, in particular Ignite thin clients, REST API, and thick clients. And here is, and again, my suggestion would be to you guys, default to the thin clients if you need to connect to Ignite from serverless functions, because it has excellent startup time, it supports multiple languages. It's a feature set, even though it's not the same as with the thick clients, you remember it's getting more feature rich, so that gap will be shortened soon. Also, partition awareness, I was not reviewing that on the previous slides, but generally, when you connect with the thin client to your cluster by default, all the requests will go through one of the servers, which we call the proxy server. But if you want any kind of partition awareness, when you want the client to connect to a specific node that owns a key or value that you need to retrieve, then you can enable this partition awareness. The reason why I did not mention it on the previous slides is that probably you don't need to have this partition awareness in your serverless functions, because serverless functions are supposed to be used, let's say, for a short fraction in time, and then you load, unload them, and why would you need to have this partition awareness? So probably the best use case for serverless functions is like it started, it executes like 1 or 2 commands, and then it can be unloaded anytime. And that's how you save your costs. But anyway, if you see that your traffic to the serverless function is consistent, then you can enable partition awareness for the thin clients. And the REST protocol, when it comes to the REST protocol, you can default to the REST protocol if, let's say, you need Graal VM native image. Otherwise, I don't see any reason. You can always use the thin clients. And thick clients, here is probably if you need any feature that is not available in thin clients or REST API, consider it as the last chance reserve. Well, another topic for the conversation right now, we see that there is a spark and growth of different cloud native and servers and frameworks that are being optimized for serverless environments that focus on the startup time of your Java functions. on the execution time of your function. And here is I just would like to share the latest news with you on this frontier, and then you can carry on your research after this, after watching this video. So generally speaking, when it comes, let's say, to such frameworks, we can consider Micronaut. And when it comes to the Micronaut, we've this week we released the very first integration between Micronaut and Apache Ignite. So generally go to this wiki page, and then you can embed, you can automatically create and start Ignite inside of your Micronaut services and serverless functions. Also, Ignite historically supports Spring Boot, so also there is a lot of automation in place. When it comes to other frameworks, or when any integration does not fully satisfy all your needs, you can always work with your favorite framework that is used for your serverless functions, and then select either the thin client or Ignite REST protocol, to achieve the fast startup time of your function, and then just, use all the APIs exposed in those connectivity options. It's pretty simple. So I would not, spend more time here discussing any internals. If you have any questions on the connectivity options or on these frameworks, please feel free to leave them in the chat window, and I will be pleased to discuss them once I finish with this presentation. All right, as it was promised, let's take a break. Right now, I want to demo you how to create the very first serverless function. Probably most of you have already done this before, but there is always a group of people who are going to do this for the first time. And let's imagine that I'm tasked to create that function. What I already have deployed, I have here it is. I have two nodes Kubernetes cluster running in Azure cloud, and I've deployed. I also loaded. So let me show you what's the version of Ignite is running there in Azure. I need to execute this command. Actually, I am using this HTTP protocol, and I'm saying, all right, what's the version? The version of Ignite is 2.8. Good. Also, I have already preloaded a sample database. So let me do this right now. I want to connect to this database, to that cluster using JDBC driver of Ignite. It uses thin protocol. So we were not discussing these drivers because, in fact, all these drivers are reusing the thin protocol of Ignite, so it doesn't matter. And the address of my Kubernetes service that will accept requests and forward them to the client, to the server nodes, is as follows. All right, I could connect to the Kubernetes cluster, and let me show you the tables I created before. So generally, that's what I have. I have created the so-called world database that has information about cities that are located in various countries, and also we store the table of country languages. So basically, just to understand what languages people speak at a specific country, in a specific country. And next, we are going. Let me execute this query. I want to select all the cities with the population bigger than the provided one. To do that, let me select city name, its population, then its country code. I want to know the country name. We are selecting from city, where population, let's say, is right now, let it be bigger than 8 million. And also, I want to order by population in the descending order. Okay, that's the answer. The most populated cities, from the most populated, it's Mumbai, Bombay, then Seoul, Sao Paulo, etc. And our next task is to create a serverless function that will be accepting requests and that will be returning the most populated cities, taking your population parameter that you provide as an argument in that function. So generally, we want to create a function that will be executing this query, connecting to Ignite cluster, to that Ignite cluster, and returning the final result to you. Okay, that's our goal. So how do we approach this goal? Let me go and create a project from scratch. Make dir, I will create temp dir. Let me go to the temp dir, and I'm going to use a special Maven command to generate a project that will have all the different parameters set if I want to deploy that function in Azure cloud. So I need to use this command, maven archetype generate. Then we are setting this archetype group ID. The group ID is Microsoft Azure, and archetype artifact ID is Azure Functions archetype. All right, and also we need to specify Java version. It has to be Java 8. All right, hopefully I did not have any misprints. Okay, the project is being generated, so it's being generated from this archetype. We will have a lot of the templates. Okay, the group ID. Okay, let's do something simple. Demo, and version 1 of the project. Okay, package name, let it be demo. It's all simple. Okay, checking all the parameters, and we are ready to create the project. All right, the project has been created. Here it is, and now let's open this project and create our function that will be accepting requests related to the most populated cities, and it will be connecting to the Ignite cluster. I will be using IntelliJ IDEA because that project is possible to open using with Maven and POM.xml files. Let's just open it. It's located in here, demo. You've just created it. So once it's opened, definitely this project doesn't have any artifacts of Apache Ignite. And as long as for this project, I'm going to connect to the cluster using the thin client, the option that I encourage you to use by default. And what I need to do next, that's the project. I want to open this POM.xml file, and I want to add Ignite dependency. I want to add Ignite core module org Apache Ignite, and we are talking about Ignite core, and I need a version. 2.8.0, the one that has been used on the server side. All right, enable auto import. Let's give some time Maven to pull in all these artifacts. And once this happens, the next stuff is we need to create our serverless function, right? And luckily, we already have a template for this function. This template, just a sample a hello world application. And I want to change it. As you remember, my task is to create the function that will basically execute the following query in the Ignite cluster. So what I'm going to do next, it means that I'm expecting to receive the population parameter in a user request. So let's rename this, rename all occurrences. So the function, the template is already pretty usable. So if the population parameter is not passed, then they're going to respond with an error message. Otherwise, we need to connect to the Ignite cluster and execute this command. So let's create Ignite client reference here, and I'm putting it in here because the chances are high that this function will not be unloaded right away once I execute the very first command, and I want just to reuse this connection if the same function is going to be used between different calls to the API. Okay, so what we are going to do next? First of all, I need to create client configuration. We need to know the address of our cluster. And let me copy this address because it's hard to remember it. Okay, that's the address. And after that, I need to do it this way, set address. And after that, we are connecting using Ignition API, start client using this configuration. Once the client is connected, we want to execute that SQL fields query, SQL fields query, no SQL fields query, and that's the query we need to run, except for the population parameter will be passed into this query, and that's the argument. The argument you, like our users, will be passing this argument, and also we need to set the schema name because those tables were created in the public schema. And that's the schema, the default and the only one schema that is supported by Ignite right now. All right, once we create this query, let me kind of copy and paste the rest of the implementation because it's not that interesting. What we are doing next, like once we need to execute this query, we executing this query here, and then we basically parsing the result set and appending this result set to the string builder. And finally, once we parse the whole result set, we need to do this. We are doing builder to string. That's it. That's our function. And next, let's build this function. What's interesting is that you don't need to deploy the function to right in the cloud to test it. We can test the function locally, and there are special APIs for that. But before we do this, I need to build this function using Java 8 because in Azure, Java, like only Java 8 is supported at the moment. At least that was the case yesterday. Okay, let me check my Java version. What's the Java version? No, that's not the version I need. I need to switch to, I'm using SDK tool. I'm saying SDK use Java 8. I have this Java 8 to 265 Zulu. I'm using Zulu. All right, I switched. Let me check that I have the right Java version. Okay, we are good to go. In the next command, you know it. We need to clean and package everything. Clean package, and I want to skip tests. I don't want to run any tests because they will fail. All right, something is being downloaded. Good, good, good. Come on. Okay, the artifact is ready. And what we want to do next, I want to deploy and test this function locally. For that, Microsoft Azure allows you to execute this goal with maven Azure functions, run command, and this run command will launch your function locally. If I did not do any mistake, yep, we should be able to try out our function right now. All right, my function has already been deployed locally. Okay, I should have renamed it, but anyway, let's skip it for now. That's the address. Let me copy it, open another terminal window. I'm going to use curl. And if I execute this command as is, you see I will be pushed back saying that I need to pass in this population parameter. That's why I'm saying, okay, please return me all the cities with the population bigger than 8 million. Okay, and that's the same result set we observed when we were using their SQL driver that was connected to the cluster. It's all the same, it's all simple. And that's how simple that stuff is. And basically the assumption of this, that this serverless function will not be used all the times, it will be used rather infrequently, and you don't want to have it running all the times in your cloud environment. You want to pay only for what you use. So that's like simple command. Imagine that you have someone who wants, to, depending on the population value, a person wants to get the most populated cities, and you have this function developed. That's it. So in the next step, the most prominent step is let's deploy this function to the cloud, and we need to execute this final command, maven Azure functions deploy. So right now it probably will take between 1, 2, 3, or even 5 minutes. It depends on how swift Azure will be with the deployment of my function. That's why I will leave this thing at this. We will go back to the slides. We will finish our presentation. And after that, at the end, we will get back to the source code and we will double check and try out our function, confirming that it was successfully deployed in the cloud. All right. Going back to the slides. Okay, and the final topic that I wanted to touch upon this time is Ignite cluster deployment options. And it depends. Do you need a self-service? Are you going to do? Do you need the self-service, meaning that you will be managing, deploying, upgrading all your clusters, or you're looking for a managed service option? So here is when to talk about the self-service. Basically, in the cloud environments, we all know we have two primary options. We can deploy it in virtual machines, so you can use Kubernetes. And here is, guys, I don't have any permission to, let's say, require you to use any of these options. It's really up to you. I used to work with, I worked with many architects and developers who prefer to deploy Apache Ignite clusters in virtual machines, just because they deploy all databases in virtual machines. Let it be Oracle, Postgres, or Cassandra, or Ignite. That's the practice at those companies. They always deploy databases like Ignite, etc., in virtual machines. And then, but the applications, the same companies use Kubernetes for the applications deployment. Using that, they will be using Ignite thick or thin clients to connect to their to an Ignite cluster that is running on virtual machine. At the same time, I can give you a lot of the examples when architects decide to deploy the whole solution, including Ignite server nodes, the cluster, and applications inside of the Kubernetes. And that's also a reasonable approach. It just depends on how exactly you are going to manage everything in production, what's your strategy, what's your preference, etc., etc. So consider two options and then decide like on your own specificities. So here is just Google for, we have a lot of materials on the deployment options for clouds and Kubernetes. Just Google for them and you can find a lot of details, at least if you go to the GridGain technical documentation. And that's about self-service, right? That's when you are going to deploy everything, when you're going to patch your cluster, upgrade your cluster, do backups of your cluster, etc. If any of you is looking for a fully managed service, like with serverless functions, like with serverless functions, we are deploying our code, and then someone sits and manages the function load for us. Someone can deploy another instance of a serverless function. Someone can probably allocate more resources for your serverless function execution. And the same idea applies to your Ignite clusters or GridGain clusters management and monitoring. If you need a fully managed service, take a look at GridGain Nebula product. That's the managed service for Apache Ignite. So that's when we have a team of experts sitting and generally deploying, patching, upgrading, scaling, and optimizing your Ignite solution, Ignite clusters for you, so that you can focus only on the code. So that serverless functions are managed by your cloud provider, GridGain or Ignite clusters are managed by GridGain, and then you can just write your code and don't worry about any deployment aspects. Wrapping up, let's summarize in here. So generally speaking, when we're talking about serverless functions, we are talking about cost reductions. And those of you who are on this call today or watching this recording, you most likely already deployed your solutions in the cloud, and you are already deploying Ignite there or moving Ignite to a cloud environment, and you're also considering or already using serverless functions as one of the connectivity options. And as I said, when it comes to the serverless functions, what matters most is the function execution time that breaks down into startup time and the logic execution time. So, and with Ignite, we have a pretty big number of different connectivity options. And hopefully by the end of this talk, you understand what's the connectivity option you go for when you develop your very first Ignite serverless function. If you'd like to learn more, if you'd like to dig deeper, so for instance, if you want to deploy, if you have never developed any serverless function with Ignite before, you can check this tutorial, Deploying Ignite with Serverless Functions. It's created for Azure, but also we are planning to create similar ones for AWS, Google Compute Engine in our foreseeable future. Also, if you're using any frameworks such as Micronaut, check another tutorial that gives you more details on how to connect and start. And finally, serverless architectures. If there is any of you who is new to the serverless architectures concept, I'm advising you to read this article, the last third reference, that basically explains not only the benefits of serverless architectures, but also the drawbacks, consequences, and generally how you should go about, selecting whether you generally need a serverless function or not. And final closing words, that was one of the formats. We collaborate with you, we are talking to you guys, but also keep an eye on our virtual meetups where we are where we are gathering together with community members and Apache Ignite users. There are some new exciting presentations are coming. Like yesterday, we had the conversation about Ignite 3.0. What's expected in that release, and there is something new is coming and will be announced soon. So just join this group and stay aware about some new interesting topics related to Ignite deployments. Okay, so as it was promised, before we switch to the questions, let me confirm that in fact my serverless function was deployed. I hope that nothing broke down. Okay, so Azure reports that everything went fine. That's their URL I can trigger with curl. Let's do this. I am copying it. And let me go back here. That's the local function. I can terminate it. That was the local function. Okay, so right now, curl, HTTP example, population. Let's go for 5 million. All right. I think that like with the very first call, it takes more time. I don't know, to start some reason, some optimizations. I'm deploying on a small machine, but that's the answer. I think if you keep executing it, every next call will be much faster because the function is already so loaded. Probably it's not unloaded, and you can kind of execute it many times. If I change the criteria, like 8 million, right? It also executes really fast. So that's it. Like, so what we've done throughout this last 30-40 minutes, we discussed the connectivity option. As I said, that was the recap of my very first research, where I wanted to share with you my findings on what are the best connectivity options for Ignite, depending on your requirements. But expect new material coming in this direction because we see the demand. We see that many more application developers of Ignite deploy Ignite and serverless functions. We have already opened several optimizations related to serverless deployments on the community end, and also we are going to schedule consequent talks, develop new tutorials related to serverless functions. If you have any suggestions, always you can reach us out on the user list or just drop a note in this chat window. All right, I'm done. Venkat, do you have any questions?
First question I had, Denis, was, serverless functions, you got to, you have to make sure that they're optimized, right? Otherwise, there's a lot of, there's a cost component to it. How do you recommend optimizing, the queries and the code so that, it takes the least amount of resources when you run it, especially in a distributed environment?
Yeah, so here that's again, if to reiterate on this point, first of all, what Venkat is, what this question is all about. Let's say if your function executes, it takes like 1 second to execute your function, one function, but 20 milliseconds to execute the other function. It means that you will be paying 5 times less for the second function, and that's the goal. That's the good epitome of how you need to approach all those serverless functions. They are supposed to be used for a short period in time, and they should be executed the fastest way possible, because the faster they execute, the less you pay. And here is, as it was said, first focus on the startup time, because before this function will be accessed, and before it will process the very first request, it has to be loaded by your cloud provider. And when it comes to Ignite, that's why I decided to spend most of the time discussing connectivity options. Select the connectivity option you need, right? And probably thin clients is the best way to go here. Once you do this, then it depends on how exactly your architecture looks like. Probably you need to measure if your local function execution time, like local logic that is being executed by function, is really fast and you don't have anything else to do about it. Just see how you can optimize the remote logic execution time. The time it takes, let's say, to process a query in the Ignite cluster, probably you need to create special index if you're running SQL queries in Ignite, etc. Or you might need to do some other server-side related optimizations, which are basically not related to function, but they affect the function execution time. And finally, if we talk about, let's say, Java serverless functions, then the holy grail of the future is Graal VM, because Graal VM helps you to create native images that are bootstrapped much faster. And many know that Java is notoriously has a bad reputation for serverless functions because its startup time is high. And with Graal VM, it's kind of possible to shorten that startup time dramatically. And right now, if you need that stuff, use REST API of Ignite. But I would say that with Graal VM, the cloud vendors do not move rapidly. For instance, AWS, I was trying to create for this webinar, I was trying to create an example of a native image for Graal VM that runs a serverless function, but I discovered that for Azure, Microsoft Azure does not support that feature yet. Only AWS allows you to create a native image and deploy it, meaning that that did not become a mainstream. So we need to wait. But that's probably what I would. So as a summary, focus on the startup time, then check if your local execution time of the function is good enough. Then see how you can optimize the remote part when your function executes or like depends on any remote database like Ignite cluster or any third-party service. So probably you would need to optimize that part as well.
Great, thanks for that. The next question is about your the IP address. So it says in the demo, you had this hard-coded the IP address. Can the cluster get auto-discovered for serverless functions?
And actually, yeah, that's the good point. So I would say that with the thick clients that are not the best choice, the auto discovery is supported. With the thin clients, right now you have to provide at least one IP address of your server, but generally people provide more addresses so that a client can connect to any of the server. How you can go about this? You can generally, in this case, you have two options how you can create your function more generic so that you do not hardcode an IP address. You can create a DNS name, because in this case, that's the IP address of my Kubernetes service. So this Kubernetes service receives this request and then basically kind of connects to the Ignite pods, right, to the Ignite cluster nodes running locally. And you can create some DNS name for that service. So, something that can be embedded in the code. Also, I know that there are some discussions on the Ignite dev list related to that auto discovery of the thin clients when your cluster is deployed in Kubernetes. So generally, it should be possible in the nearest future to, let's say, to provide some address, like Kubernetes specific address, let's say to some Kubernetes service, and then the thin client will be able to auto discover everything. That's coming, but as of now, try to create a DNS name for your service in Kubernetes.
Cool. I have a couple of questions from Shrikant. One is about how does the startup time for Graal VM compare with thin clients and thick clients?
So as I said, with thin clients and thick clients, I mean, if you're talking about the native image generation, so right now you will not be able to use this feature with thin or thick clients because we use a lot of reflection code, we use unsafe, and that will be improved only in the foreseeable future. So there I don't have any specific numbers. But let's say if you use REST protocol, you just can create a simple application, let's say, that uses Ignite and connects to Ignite using this REST protocol, and you will see that the change will be dramatic. For instance, recently I was experimenting with a Micronaut framework. I created one application that was running on a hotspot Java virtual machine. The startup time probably was around 200 or 300 milliseconds, if to be precise. And when I generated a native image and switched to Graal VM, it like the startup time reduced like it was 10 times faster. Instead of 200 milliseconds, it was like 20 milliseconds, something like that. I don't want to confuse you, but that's like that will be definitely an order of magnitude difference in terms of startup time.
Cool.
And with Graal VM, but with Graal VM, if you are new to this, if you do not use this virtual machine yet, keep in mind that it's not available it's not a GA version yet. It's like it's being released, but it's released as a release candidate, etc., etc. But I think that pretty soon that should become one of the mainstream virtual machines, at least for the serverless environments where the startup time matters, and when you start and restart your functions frequently.
Yeah, Shrikant is saying unikernels have, they promise, shorter startup times. And this other question is, do you support OSV unikernels in your managed services offering? Is what he's asking, I think. So Nebula, does it support OSV unikernels?
Yeah, so here is my best answer would be, I cannot speak about all the internal details of GridGain Nebula managed service offering, but I do know that this service exists for and right now available for all the major cloud environments, like private or public. So here is if you have any, but I think that it's all doable. I mean, it's all about going and talking to GridGain directly, sharing your use case, your requirements, and then you will be explained if it's possible to manage it, and yeah, most likely yes, then how everything will look like.
All right, and maybe one last question. What would the size of a serverless application be compared to a microservice application?
I think that, and here is me again. So here it's not about even the size. When I think about this, sometimes it's all about size, because it definitely will take more time to load a big jar file, right? But when you're comparing microservices and serverless functions, think differently. Consider serverless functions for operations or requests or APIs that are not hot, that are not being executed all the time, so that you don't want to waste your resources of your cloud environment. Instead, if you have some hot functions that are used all the times, that are executed, like let's say hundreds of thousands times a second, then for sure just deploy services, because it will be cheaper for you. It will be more cost effective. But when it comes to serverless functions, all right, you have some among those, let's say your business APIs, you have a few of them that are executed, let's say once a minute, or probably like once, I don't know, once an hour, like several times an hour. Then those deploy a serverless function. That's my vision. And but also when it comes to the size of your service or your function, I was not doing any measurements, but after doing this research and getting to this territory of the Graal VM, when it generates into this native image can boast not only about the fast startup time, but also the size of your native image will be much slower, because generally that will be binary code. That's supposed to be executed. So inside of that native image, you will have a special kind of core sort of Java virtual machine that does some operations related to GVM, but that will be a completely different beast, and that the size of that native image should be compact.
Okay, so that brings us to the end of the presentation. Thanks, Denis. Thanks, everyone.
Bye. Thanks, everybody. Bye-bye.